Okay, this is our last section in chapter 11. Okay, and notice we're graphing linear inequalities. So we're still graphing because we still have an x and a y, but instead of an equation, we're going to have a less than or equal, greater than or equal. So the first thing I need to do is find where it's actually equal. Notice on this one, it's less than or equal. So I can just imagine that I need to graph the line where 2x plus 3y equals 6. Right? Now, the x and y is on the same side. So this is my intercept method, right? The intercept method. I'm going to let x be 0 and y be 0. Because if x is 0, this is gone. So 3 times 2 is 6. If y is 0, this is gone. 2 times 3. And I've got my 2 points. 0, 2, and 3, 0. Now, if I just drew a line through there, that's where it's actually equal. And I'm going to do that because this one says or equal. So that's actually part of my answer because I want where it's greater than or equal 6. Now, if it just said strictly less than, I would still find this line, but when I drew it in, because the equal part wouldn't be part of my answer, I would make it a dotted line. So this would still be my boundary, but the actual line wouldn't be part of my answer, and we represent that by drawing it dotted. Okay, so think about what this means. This is where the equation is equal to 6. Let's think about just a regular number line where we just had one variable instead of 2 to kind of simplify it a little bit. And let's say that's where it equals 6. Notice on one side of 6, everything is bigger than 6. On the other side of 6, everything is smaller than 6. That's what happens on either side of where something's equal. One side everything's bigger, the other side everything's littler. So I want to know which side of this line will be the less than part. Well, an easy thing to do would be to take this point 0, 0 and just plug in for your x and y. So that would mean 0 plus 0, and I'm going to ask myself the question, is 0 less than 6? If it is less than 6, then that means that's part of my answer. That means every point over here will be less than 6, just like every point on this side is less than 6. So I would shade that side. Okay, so it's exactly the same as graphing those lines, except we have 2 extra steps to consider. Is our line solid or dotted? And that's based on, is it strictly less than, or is it have the equal part? And then which side do I shade? All right, so let's look at another one. Hey, this one is set up again for the intercept method because the x and y is on the same side. So if x is 0, y is 3. If y is 0, it doesn't go evenly, but look, it's just a one step. What would it be if you divide both sides by 2? Oh, 3 over 2. Right? So x would be 3 over 2, which is 1.5. 1.5. If you want to solve that thing for y and do the slope intercept, you could do that. Okay, but that would require some extra steps. Now, on this one, I don't have the equal to part. So when I draw my line, I got to remember to draw it in as a dotted line. Right, I got to remember to draw it in as dotted because this isn't actually part of my answer. It's still the boundary line where it changes from less than to greater than. It's where it's equal, but I don't want the equal part to be part of my answer. Okay, so am I going to shade this half or this half? Well, let's take this point right here, 0, 0, and let's plug it in. So 0 plus 0 would be 0. Is 0 bigger than 3? No, it's not bigger than 3. So this side is not my answer. I need to shade the other side. Okay, and that's all there is to graphing inequalities. Okay, this one's solved for y. So I'm going to use my slope-intercept. The slope is 3, but what's the y-intercept? Yeah, if there's not a number written over there, it must be because it's 0, right? So my y-intercept is 0. Slope is 3 over 1. Up 3 over 1. Or I could say -3, -1. Negative is a positive. Okay, am I going to draw a solid line or a dotted line? Yep, dotted, because I don't have the equal part. All right, so a dotted line. Hey, look on this one. If your line goes through 0, 0, I can't use that point for checking. Right, I can't, because look what I, 0 less than 0, what? It's equal to 0, but it's also not on the side. So you can use any point you want. You could use this point up here, but I like to use a point that makes my math easy. And some people might want to use 1, 0, but I'm going to use 1, 1, just because then I don't have to quite worry about mixing up my x and y. That's why 0, 0 is nice. X and y is the same. So 1, 1. So that would be, is 1 less than 3? Yes, 1 is less than 3. This is my answer side. Okay. How would you go about graphing this thing? Do you notice anything? One letter. It's special, 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 right? So solve it for that letter. And then other stuff out the window. I just got to think this through. Here's x. Here's x negative. Okay, it's the vertical line. It's the vertical line. Okay, it's dotted. And I could still pick this point and plug in as 0 less than -4. No, so I'd shade the other side. But when I get a horizontal or vertical line, I'm really only talking about that one axis, the one number line. So I know this is the side that's less than -4. All these numbers are greater than. But again, I could still plug in 0 and say, oh yeah, 0 less than -4. Nope, don't shade that side. All right, one more. Okay, this one is really, really tricky because it's not set up for any of my methods. Look, the x and y is not on the same side, and it's not solved for y. So I got to do one of those things. It doesn't matter which one, right? I'm going to, well, I'm going to do it both ways. How about that? So first of all, I'm going to put the x and y on the same side. So I'm going to add 2y to both sides. Right, and I got it great, and I'm going to subtract 6. Okay, just so we can see there's a pitfall here I got to be careful of. But if I add 2y to both sides, it's gone here, plus 2y over here. If I subtract 6, it's gone here, minus 6 over there. Okay, so if my x is 0, y equals -3. If my y is 0, x equals -3. Okay, dotted line. And before we decide our shading, let's just look at what if we wanted to solve it for y. Okay, a couple of things I got to be careful of. If I'm going to turn this around so that my y is on the left-hand side, I got to make sure this faces the same direction. The little side has to continue pointing to the y. And the big side has to continue pointing to the 2x plus 6, right? So I kind of flipped it around, but that means that has to flip. Okay, now if I'm solving for y, I'm going to divide by -2. But remember, when we have an inequality sign and you divide by a negative, you got to change the sign of the inequality. Right? Okay, so when it's like this, my y-intercept is -3. Oh, okay. And the slope of -1. Down 1. Uh-oh. Is my slope -1? Divide by -2. Because see, look, this has a positive slope. Let me see what's, oh, because that's not -3 like we said. Okay, so that was a good catch for us. All right, let's go back to where I'm doing it in red. If x is 0, y is -3. We had that right. But if y is 0, x is -3. Okay, dotted line. Okay, sorry about that. Now, let's get back to where we were. The y-intercept is -3, and the slope is -1, which either means I've got to go down 1 and then +1, or up 1 and backwards 1. Notice we're going to get the same line. Same line. Okay, so now I'm going to pick this point 0, 0. If I plug in up here, my question is 0 bigger than -6? Yes, it is. If I plugged in right here, I'd have is 0 bigger than -3? Yes, it is. Either way, of course, we have to have the same graph. We were just graphing this same equation in a couple of different ways. But just be careful if you're solving an inequality, when you divide by a negative, you got to flip that sign. And you got to be careful if you move things around to keep the inequality pointing in the correct position that it started out being. Okay, so that finishes up chapter 11.